Okay, so last unit we were talking about the atomic models. We learned about two models. We learned about Thomson's model, which was the plum pudding model, right? And he said that protons, neutrons, and electrons were all just nicely mixed together, right? Then Rutherford came along and said, nope, that doesn't really make sense. So Rutherford came along with the model, and he said protons and neutrons are in the center, and electrons are orbiting around the center, kind of like planets orbit around the sun, correct? Okay. However, his model could not explain why elements had the chemical properties they had. It couldn't explain why all of the first column react really violently with water. It couldn't explain why the carbon column does not react with water. It couldn't explain why some things have similar characteristics and why other elements don't. So we needed to somehow to fix it. So somehow we needed a different model that better described the behavior of electrons without atoms. Now, one thing I like to I like to give you guys analogies in this unit to kind of help you think about Rutherford's model. He compares it to planets, but basically what he said is the sun's in the center and the planets are just around it. He didn't put them in order. He didn't talk about orbits. He just said they all move around the sun. No specific way. No specific reason. Is that true? No, because we all know that the planets go in a certain order, and we all know that their orbits are different sizes and sometimes even different shapes, right? So, Niels Bohr, he was actually a student of Rutherford's, but he kind of continued Rutherford's work. He thought that Rutherford's nuclear model needed to be altered a little bit. He said it needed to be improved. He said, yes, the electrons do revolve around the nucleus, but we need to be a little bit more specific than that. So in 1913, he changed the model to include information on how the energy of an atom changes as it emits or absorbs light. So in order for us to continue, we first of all need to talk about light. What is light? It is a type of something. Energy. It is a type of energy. So whenever you guys are seeing light, you're seeing energy being given off in the form of light. That's how you can see it. So electrons release and absorb energy in the form of light. So every single time light hits an atom, it causes the electrons to move. They absorb energy, but at some point in time they have to give it back off and they release energy, so that's how you see all the light around you. That's why you see different colors. That's why when you turn the light on, all of a sudden you can start to see things. That's why in the gym, when you turn the light on in the gym in there, doesn't it take it a while for them to turn on? Okay, because the electrons have to absorb light, and then they have to get excited. This is what you call it. They get excited, they jump energy levels, and then eventually they give that energy back off in the form of light. So it's almost like a chain reaction. Once you turn on the light, it gets brighter and brighter and brighter and brighter because the reaction is happening faster and faster. Okay, the Bohr model, he said that electrons are found in specific circular paths. So basically, Rutherford said, yeah, the planets orbit the sun. But Bohr said, well, let's put them in order and let's give them specific orbits. So for instance, Earth is in the third orbit, right? He gives each electron a specific orbit. So for instance, sodium, its outermost energy level, or its outermost electron lives in the third energy level. He gives each electron a specific orbital, specific spot around the nucleus. Okay, in order to do this, he studied the hydrogen atom, and from his experiments, he was able to incorporate two ideas. First of all, there are something called energy levels, which there are 7 of them. And secondly, he came up with the idea of something called quantum. Quantum, for some reason, is a really hard definition for us to remember. But all quantum means is the amount of energy. So if I'm talking about light quantum, I'm talking about the amount of energy in the form of light. So he studied light and energy levels. However, his model is not perfect. Okay. It also failed to explain why atoms with more than one electron absorb or emit energy, because he only studied hydrogen. Hydrogen only has one electron. So it's kind of hard to give all of this other information about electrons if we're only studying an atom with one electron. Okay, so I just told you that there are 7 energy levels, right? Okay, how many rows are on the periodic table? So everybody look up there and count. How many rows? 7. 7 energy levels, 7 rows. 7 energy levels, 7 rows. Coincidence? I think not. Okay, then if you look at the energy levels, the first can hold 2, the second can hold 8, the third can hold 18, which in physical science you learned that the third could also hold 8. We stopped at the third energy level in physical science, right? Not now. Okay. So the third can hold 18, the fourth can hold 32, the fifth can hold 32, the sixth goes back to 18, and then the seventh goes back to 8. So let's look up at the periodic table again. How many elements are in the first row? 2. How many can the first energy level hold?
2.
Coincidence? Nope. How many elements are in the third row? 8. How many can the second energy level hold?
8.
Coincidence?
I think not.
But then, what happens now? There's 8 in the third row, but how many can the third row hold? 18. Okay, the Bohr model is not perfect. It is not 100% correct, which is why there's actually another model that we're going to talk about tomorrow. Because Bohr's model, yes, does talk about electrons in it, and yes, it does talk about energy levels, but it forgets to say electrons don't always have, you don't have to fill the third energy level before you start putting them in the fourth energy level. So it kind of fails. So tomorrow we're going to learn about the next one, and it's going to give you a few rules. But for the most part, if we can, everyone in this room can count to 32, right? So is there any need to memorize this? No, because we can all look up there and we can count. And tomorrow, after I teach you a few cheater ways, okay, we're going to be able to use the periodic table to look up all of this information. Okay, so I really like this picture too. If you guys look at this picture up here, we see an apartment building, right? Okay, whenever I am teaching you guys how to do this chapter, I always compare it to an apartment complex. Because if you're going to visit somebody in an apartment complex, you first of all have to know what building, because there's usually multiple buildings, right? Then you have to know what floor. Then you have to know what apartment. Okay, so this is very similar to how we do electrons. We have to know what floor. So if you look at this apartment building, what do you guys notice about the floors? They get smaller and smaller and smaller as they go up, which is relating to atoms. As you go out in an atom, as you go outwards from the nucleus towards the outer energy level, they get closer and closer and closer to each other. So the distance between the first and the second energy level is much higher than the distance between the sixth and the seventh. So they start getting closer and closer and closer and closer to each other. Okay, so energy levels are kind of similar to the rungs on a ladder. Everyone in this room has probably climbed up a ladder before. The lowest rung represents the lowest energy level. As you go up, you get higher and higher and higher energy. That's why if you fall off a ladder at the 8th rung, is it going to hurt?
Probably.
Yes. If you fall off a ladder at the 1st rung, is it going to hurt?
No.
It's probably not. You're probably going to catch yourself, right?
Maybe.
Okay. Well, electrons can jump from one energy level to the next. However, they are never in between energy levels. So just like when you're trying to climb your ladder, when you go from the 1st to the 2nd rung, if your foot only goes halfway, what's going to happen? It falls back down to the 1st rung, right? You can't ever, when you're climbing a ladder, you can't put your foot halfway through. You have to go all or nothing. There's no in between. Same thing for electrons. Electrons are never in between. They're either in one energy level or the other. They're never in between. They move really fast, so when they jump and move, it happens almost instantaneous, okay? In order for them to move energy, or in order for them to move levels, they have to have energy. Where do you think they get this energy from? Talked about at the beginning. Light. In order for them to move energy levels, they have to absorb energy in the form of light. Okay? The higher the energy level, the farther away from the nucleus it is. So, electrons in the 7th energy level have more energy than electrons in the 1st energy level. The farther you are away from the nucleus, the more energy that energy level contains. Okay, so next let's talk about electrons a little bit. The amount of energy gained or lost is not always the same. So like I just said, the distance between the first and the second energy level is more than the distance between the sixth and the seventh, right? So therefore, it's going to take more energy to move between the first and second than it would the sixth and seventh. So just because they're all energy levels does not mean they're all equals. Think about the orbits we do around the sun. Are all of our orbits the same? No. Isn't it going to take more energy for you to orbit around Pluto's, even though Pluto may not be a planet? Isn't it going to take more energy for you to go through Pluto's one orbit than it will Earth's one orbit? Yeah. Why? Because it's much bigger, right? Okay, so it takes more energy the farther you get out, and higher energy levels start to become closer to each other. Okay, and I wanted to spend another minute talking about quantum because this is the most commonly missed question on the test. For whatever reason, quantum is really hard. Quantum just means the amount of energy required to move an electron from one energy level to another. And then this statement is on your homework and on your test. It says energy of an electron is quantized. What in the world does that mean? Okay, it means electrons absorb energy in the form of light, and then they release energy in the form of light. So, if it is quantized, it means that they are absorbing and releasing energy through light. So, if I say that an electron has gained a light quanta, what am I saying? It has gained energy from light. If I say it has released a light quanta, what am I telling you? It's releasing light energy, correct? So quantum is talking about the amount of energy. Light is telling you the type of energy. Electrons gain, absorb, and release energy in the form of light. So, first of all, let's do a little bit of practice with drawing the Bohr model. It's been a while since we've done this. We did it freshman year, but we've slept since then. So I want us to all practice. We're all going to do silicon as our example. Okay, so when you're drawing the Bohr model, the first step is to write the symbol in the middle as the nucleus. So what's the symbol for silicon? SI. SI, so I write. Okay, what row is silicon in? Third, so it means it has
Energy level.
It has 3 energy levels. Each row in the periodic table is representing a new energy level. So I'm going to draw 3 circles. Right? How many electrons does silicon have? 14, because its atomic number is 14. Okay, silicon has 14 electrons. So basically what we are doing right now is we are trying to find a home for all 14 of silicon's electrons. So how many electrons can live in the first energy level? 2. So I do 1, 2. How many electrons can live in the second? So I do 1, 2, 3, 4, 5, 6, 7, 8. Okay, so now we're at 10. We found a home for 10 electrons, but we still have 4 left. So how many are going to be in the third energy level? 4. How many can it hold? 8. So is it going to be full? No. So there is the Bohr model for silicon. Done. Now, did anyone ever notice how in physical science we never drew Bohr models past number 18? Did anyone ever notice that? Why do you think we never drew a Bohr model for a tougher element? Because the Bohr model is not right. What do I mean by that? Well, let's try potassium. Potassium is the next one that I want you to do, but we're going to do it as a class. So, if I draw the Bohr model for potassium, we put K in the middle. What row is potassium in? The fourth, which means what? 4 energy levels, so 1, 2, 3, 4. How many electrons does potassium have?
19.
19. So we put 2 in the first. We put 8 in the second. How many electrons can the third energy level hold? 18. But where Bohr's model fails, which I talked about a little bit before, is Bohr's model never says, well, they don't have to necessarily, you don't have to fill the third energy level before you move to the fourth, because doesn't potassium need a fourth energy level?
Yeah.
If you had to guess, how many electrons would be in the fourth energy level? 1. Why would we guess 1? Because he's in the first column. So I would assume that there are 1 electron out here. So now we have 10, 11. So how many do you actually think are in the third energy level?
8.
3, 4, 5, 6, 7, 8. This is why freshman year we never had you draw it past 18, because the after you get past the third energy level, things don't work as pretty as we want them to. But tomorrow we're going to learn why. But today what I want you to do is I want you to try to draw the Bohr diagram for the rest of these elements to your best ability. I'm really not going to grade them for right or wrong. Either fill the orbitals up and leave some empty, or try to figure out how many go in each one, so on and so forth. But I gave you some that are not going to work out nice and pretty to give you some practice and to help you figure out why Bohr's model does not work. Okay? After you have tried those, I actually have put, you have 4 homework questions on the website. It's today, due tomorrow, 10/10/2013. Here are the 4 questions. Here's the examples I want you to do off of that slide. This is what I want you working on. If you get stuck on the Bohr model, I am more than happy to help you. But again, like I said, I gave you examples that are not going to work out nice and pretty. So don't be alarmed if it doesn't start to work. I'm hoping that you guys are going to see that. I'm hoping you can see why Bohr's model is not correct. Okay? Get started. Bohr model. And then date it.